We've got an exciting hour ahead. We're going to show you the technology and demonstrate to you the technology that underpowers what Mark was forecasting. So we started our effort working on a new suite of technologies from Oracle over 11 years ago now. And the premise was very simple. Customers were looking, as industries digitalized, for a platform that provided capability at much faster rates than they could get with the traditional model of software delivery. So we built a suite of offerings that run in the cloud, infrastructure, platform, application software, and data as a service. And so I thought I would give you our vision for each of these areas, and we'll also show you some groundbreaking work we've been working on these past several years. Okay? Infrastructure as a service. Imagine you are a person in a project team somewhere in a company, and you get asked by your executive to get a new application up and running. And imagine you could go to a graphical user interface or an API, create an account, map the people on the projects that you wanted to groups that get permissions, and then build a completely software-defined data center. Okay? And when I say completely software-defined data center, you create a network. You could create subnets on that network. You could specify your IP address range to be used when we spin up the network. You could choose from a range of different kinds of computers and choose what kind of compute you want. You can choose from a variety of different kinds of storage and attach storage. And you could build that entire software-defined data center in less than 30 minutes. Because that's possible today. Okay? In this software-defined data center, we allow you to create accounts and manage identity, build elastic virtual networks, attach compute and storage, get a secure elastic web application firewall, and give you other services, elastic DNS, an elastic file system, elastic load balancer, and so on. Now, what underpins this infrastructure as a service is regions with very high performance data centers. So our regions are triplicate data centers. We have 3 data centers in each region, connected by a terabit per second link and less than 10 milliseconds latency. These data centers are on redundant power grids and redundant earthquake zones. So if any one goes down, you still have a couple that service your workload, so you get very high availability. Inside the data center, we have a flat network. Okay, so as we add compute and storage, any computer can talk to any other computer or any storage device with a maximum of 2 hops. And secondly, as we add more and more computers, the network scales out, and as a result, you don't get bottlenecks in the network. Okay, so it gives you not only very high performance, but very predictable performance. Attached to it, we give you the fastest Intel computers. You can get 52 Intel cores and up to 52 terabytes of local memory, delivering you 8 million I/O operations per second. So on one computer, you can load a 100 terabyte database with 2-to-1 compression and serve that 100% out of memory. We also provide the fastest NVIDIA GPUs to run AI and machine learning. Our new data centers give you 25 gigabit Ethernet to the host, which is way faster than you get in existing data centers. And we also have all flash as well as disk-based storage. So if you want something really fast, you can go all flash. If you want something cheap, you can go disk-based. From your data center, you access ours over a variety of different solutions. You can go layer 2 VPN. You can go what we call virtual private compute, where our data center literally looks like an extension of your IP address space. If you want to push a lot of data, you can buy an MPLS circuit, which gives you a 10 gigabit private leased network from a variety of carriers. And you can also direct connect to us from a variety of different peering locations. The API that you get has 3 characteristics. First of all, your network, when your traffic comes into our data center, it runs in a fully isolated layer 3 overlay virtual network. So no 2 customers can see anybody's traffic because they're in a completely private network, and we guarantee bandwidth so that 2 customers cannot swamp everybody else. Right? So we guarantee bandwidth. In a single API, you can ask for a full server, what we call a bare metal server. You can spin up a hypervisor. We'll show you a little bit how you can spin up Docker as a service. And we also support a completely serverless model, which we're going to show you. We provide a range of different kinds of storage. On the box, very fast flash and NVMe. Block storage, so you can share information across 2 instances. Elastic files, so if you have an application that needs NFS, you can do that. Object storage and archival. Today, we're expanding our regional presence, okay, to a number of places around the world, so that not only do you get this capability in Europe and North America, but you get it in a number of places around the world. And lastly, we built on top of this a variety of different solutions so that you can get a prepackaged catalog of services. So what we solved with infrastructure as a service was to allow you to get a fully elastic, software-defined data center with very high performance compute, storage, and networking, and with complete isolation for security. The largest database that runs in the cloud on our infrastructure today is a 240 terabyte database, which includes every call detail record from a telecommunications company, one of the largest in the world since 1976. So it's a pretty large database. And what are we solving with platform as a service? With platform, our central view has been, even if we gave customers a fully elastic infrastructure, the barrier to adoption to technology would be the lack of skilled people to build applications. And so we said, where do most of the skilled people, what do they spend their time doing? They're spending the time doing really mundane work, installing software, configuring software, patching it, backing it up, setting up disaster recovery. So with our platform, our work over the last 6 years has been designed to eliminate all manual labor involved in running and managing software. And we did that not by Oracle hiring an army of people that would do that, but by having the software itself do that. So we give you a fully autonomous platform that does all of these elements. You ask us for a certain size of database, as an example. You tell us how much capacity data you're going to load into it. You throw queries against it. You tell us what response time you want to the queries. You don't have to monitor it. You don't have to plan capacity expansion. You don't have to take away capacity if there's too much of it. You don't have to back it up. You don't have to patch it. You don't have to encrypt it. You don't have to set up disaster recovery. It's all done for you. And it's done by our software, not by having an army of people doing it. So this same principle we've brought to lots of different parts of our portfolio. And I'll talk about a few examples as I go today. So I'll start with database. We've introduced a fully autonomous database cloud. The benefits of it are zero cost, labor cost, full elasticity instantly. You do not need to take it down for patching, backing up, upgrade, or tuning. And we guarantee the best performance in the industry. So we're going to show you today the fully autonomous data warehouse cloud. And George Lumpkin from development is going to come up to show you that. Is George here? George, come on up. We'll show you how easy it is to use the autonomous data warehouse cloud. All you need to do is load data and run your queries. George, welcome to CloudWorld.
Hey, thank you, Thomas. Okay, so I wanted to do a quick demo and really talk about some of the key features that Thomas just discussed in our autonomous data warehouse cloud. I'm going to show you how easy it is to use the cloud because it's autonomous, how simple it is. I'm going to show you how fast and elastic it is. And then I'm going to show you how it integrates with other components in Oracle's platform, specifically Oracle Analytics Cloud. So I'm going to go ahead and get started here. We're first going to log into the cloud, and I'm going to start by creating a database. So I'm going to log in. I come into our main cloud dashboard, and we can see that Autonomous Data Warehouse is one of the products that we now have that's available for us. So I'm going to open the Service Console. And since it's the first time we've used it, we come to the welcome page that gives you tutorials. But I'm going to skip right forward and move forward to create a new data warehouse. Now, it's really simple to create a new data warehouse. All we need to have is the database name. We choose a number of CPUs, the amount of storage, and then the administrator password. Now, I went to sort of pause here and point out something, right? Sometimes when you're looking at a demo, a demonstration, you see how I'm creating the database, and you say, well, that's really simple. All those questions make sense. We need to know how many CPUs, how many databases. But what you need to realize is all the things that we're not asking you. Because this starts to be how you see that the system's autonomous. There's no questions here about what version database software you're going to run. There are no questions here about what type of disk is this system? What type of CPU should this be running on? How am I going to configure my backup and recovery? This is what the characteristic of an autonomous database is. Oracle's cloud is making these decisions and is going to automatically configure the database in an optimal way for a data warehouse workload. So let's go ahead, click Next. And we're going to quickly confirm the settings and go ahead and create our data warehouse. Now, what we're doing here is we're provisioning a new database. It's going to be on top of Exadata, so it's going to deliver great performance. We can see we started creating the service. We're building this fully secure environment. It's going to be on all the latest patches. It's going to be fully encrypted. It's set up for high availability. And there it is. It's already created. It takes us about 15 seconds to build this enterprise-ready database. So not only is it easy, you don't have to make any of the choices. We start to see how the autonomous systems are going to enable companies to innovate more rapidly. You could build a new data warehouse much more quickly than you could in the past. So now that we created this data warehouse, well, first of all, you can see on this console, we can manage the warehouse from here. We could start, we could stop it, we could scale the service up and down. And now that we created this data warehouse, we're going to switch over, and we're going to look at Oracle Analytics Cloud. This is another service, another one of our PaaS services. And Oracle Analytics Cloud provides a set of tools and capabilities to deliver enterprise BI and self-service analytics. This is how the business users are going to get data from the autonomous data warehouse cloud. Now, I've already created a project specifically for my autonomous data warehouse. Let's open the project. The autonomous data warehouse is really designed as a very scalable data warehouse. And we're not going to show data loading in today's demo. But one thing that the autonomous data warehouse has is it comes with a sample data set. And because it's a scalable service, it has a large data set. Our example data set, 6 billion records. So when you start up your database, you're going to be able to run through tutorials and so forth against this data set that we're showing here. So we have a pretty large data set. We could see a little information about this data. And let's step forward and look at the type of report that an actual business analyst might use. Our data set has sales data. So we have a quick report here. It shows profit by product, brand, and regions. And we added some other information to this report. You could see the SQL query, for example. You could also see that with our 4 CPU database, and 4 CPUs is pretty small, it's really more of a data mart. Over these 6 billion records, this report took 100 seconds to run. I had obviously pre-populated the report for the purposes of this demo. But you know what? Let's suppose that's not really the experience I want as a business user. I don't want to wait 100 seconds. So the Oracle Autonomous Data Warehouse Cloud allows you to scale elastically. So if you want to increase the performance, you can just increase the number of CPUs. Now you can do this using the Data Warehouse Cloud Console that we saw just a couple of minutes ago. You can also do this via REST API. So you can manage all of Oracle's cloud services and manage Oracle's Autonomous Data Warehouse Cloud using a REST API. And in the lower right of the screen, we'd actually add a custom visualization in Oracle Analytics Cloud, a slider bar that uses this REST API. So what we're going to do is let's say, hey, we want to increase the performance. And we could add sort of any number of CPUs we want. Let's bump up this data warehouse to 16 CPUs. So this has started now. And what's happening is, behind the scenes, we're enlarging the capacity of the existing database. And this is going to occur fully online. This is really sophisticated database technology. If there are other users running on this data warehouse, their queries continue to run uninterrupted while we scale the system from 4 CPUs to 16 CPUs. And this is a lot different than how other databases work. Some other systems actually say, well, if you want to scale the system, we need to pause your database while we recreate it on the larger hardware configuration. With Oracle's autonomous database, we can scale dynamically. So now we've scaled this to 16 CPUs. Let's go ahead and resubmit our report. So we're going to refresh the data. We're resubmitting our report. And what we're going to see here, there we go. We're going to see that with 16 CPUs, the report runs much faster, right? 13 seconds, probably acceptable for the type of thing that a business user might want to see. If we want to improve performance further, we have our hands on the knob. We can do this anytime we want to change the performance. So now that we have a high-performance data warehouse, we can start to look at a couple of other interesting reports. So this is a dashboard that has 4 visualizations. We see a map visualization. All of these visualizations are dynamic. You can see highlighting different sections of the map, highlighting different portions of the donut chart, and it gets reflected on the map. We have a couple of bar charts here on the right, and I have the ability to right-click on them and augment this with extra information. For example, I'm going to add a trend line. So we're running functions against a very large data set using Oracle Analytics Cloud to provide very interactive visualizations. And there's some other really cool features in Oracle Analytics Cloud. You know, the last feature I wanted to show within Oracle Analytics Cloud is really how this service has incorporated machine learning and natural language processing. So I could come in and just start typing an English query. Just say, hey, I want to look at sales by product. And I want to add to this, let's look at profit by customer segment. And Oracle Analytics Cloud is automatically going to recommend visualizations based upon your English query. And these visualizations are going to be fully interactive, just like we saw before. You can select a subset of data and drill in. So you get a feel for how customers can interact with the data. So now that we come to sort of wind up this demo, I wanted to show one more specific feature of Oracle's Autonomous Data Warehouse Cloud. I talked about how it's elastic. Now let's suppose that we were just had this database up for a demo, had this database up to show you. And now we're done. Now we're wrapping up the demo. Well, if we want to save money, we could take these CPUs and turn it down to 0, right? You continue to pay for storage for your data warehouse. But for CPUs, you should be paying for exactly what you need, when you need it. Say down to 0, we could come in tomorrow morning, turn on this data warehouse, and be running. So Thomas, what we've shown here is with the Oracle Autonomous Data Warehouse Cloud, we've shown how by being autonomous, it's very easy.
Yes.
There was nothing required to set up the database. I didn't really talk about day-to-day maintenance, but there's no backing up, right? There's none of these operational DBA tasks required for an autonomous database. We saw how the autonomous database is elastic. We could easily change the capacity of the database. And the key business benefit there is it allows you to save money. You pay for exactly the resources you need. And then we saw how the autonomous database is integrated with all of Oracle's other cloud services. We saw how you could visualize data using Oracle Analytics Cloud. We're really excited to introduce our first autonomous service with the Autonomous Data Warehouse Cloud. Delivers great performance, and our customers are going to love it.
Thank you, George. Great job.
Yep.
So we showed you the autonomous data warehouse. Imagine you wanted to build an application as a developer. And today you have to stand up compute, you have to install application servers, you have to configure them. So we brought the same principle to the application tier with an autonomous application platform. It supports 4 types of workloads. You can lift and shift an existing application that you have on-premise to the cloud. You can build a cloud-native application using our platform as a service. And then more importantly, we're going to show you 2 new things. A full container-native environment where you're building applications as microservices running on a Docker Kubernetes environment and a serverless platform. Okay, so the biggest thing we're trying to do is by giving you an autonomous infrastructure, allowing the developer to become the administrator and what we call DevOps. Okay, so the developer becomes the operator. He writes code, checks into the source control, kicks off his build, test, publish, deploy pipeline. It can go through any kind of workflow that you've got, including, for example, ServiceNow, if that's your ticketing system. And then you can spin up any of these different environments. Now, we're going to show you containers as part of our a container-native deployment pipeline. Lastly, we're introducing a fully autonomous serverless cloud. Okay, so what is a serverless environment? Serverless environment is, as a developer, you simply write your functions. And you say, I want to write my function, and when something changes, for example, data arrives in the object store, or I receive an HTTP web request, or an event comes in over our Kafka service, execute that function. So you focus purely on writing functions. We handle the elastic scaling and the deployment of the environment. And we provide you event hooks from lots of sources to which you can kick off the function and execute that functional code. Now, Chad Aramura from development's here. We're going to show you our containerless and serverless platform. Okay? Hey, Chad. Welcome.
Good to see you.
Okay.
Okay, so we've been talking a lot about this concept of autonomous systems and infrastructure. I'm going to carry on that theme by demoing 3 things today. Number 1, Thomas, I'm going to show just how easy it is to spin up a Kubernetes cluster on the Oracle Cloud that's fully autonomous, manages itself, automatically scales, and it's highly available. Second, I'm going to take that cluster and I'm going to provision it with common software packages directly from the Docker store, including many available by Oracle. And finally, as Thomas mentioned, I'm going to demo what we call the FN project, which is an open source serverless compute platform. So let's get started. We are going to log into our worker console here. We could possibly go wrong in a live demo. We're going to go right to the clusters tab. And as you can see, I have a number of Kubernetes clusters already running. I'm going to create a new one. And I'm going to choose an organization, which is my enterprise. And then while that's happening, I'm going to put an OSID in to tell it which tenant to deploy it into. And when I click Next, all I have to do is give it a name, my K8s cluster, Kubernetes version 1.8.5. Click Next, looks good. Let's make this thing really big. Let's give it some bare metal standard 36 Oracle CPUs. And this is the last time I'm going to deal with anything that's related to the server, because everything from here on auto scales and Oracle Linux 7.4, and boom. That's how easy it is to launch a Kubernetes cluster on the Oracle Cloud. And this thing is fully autonomous. We've been talking a lot about security today and patching. This thing will automatically patch itself to ensure that you are always on the latest versions that you need to be secure in your enterprise. Now, while that's provisioning, I've already got a cluster running, so I'm going to turn to the Docker store. Inside the Docker store, you'll find a lot of common software packages that you want to use in your organization. Well, it turns out that Oracle actually has a bunch available. You can find things like the WebLogic Server, Database Enterprise Edition, and the MySQL Server. So we're going to choose a couple of these, and instead of just doing a standard Docker pull, which I could do to get these directly out of the store, I'm going to create what we call a pipeline. And by doing that, I can go into the marketplace, I can search for WebLogic, and I've got a WebLogic step, and I can take just a couple lines here. It's literally 2 lines, and I can combine all of these pieces into what we call a worker.yml file. And once I do that, I've already created one. I get a pipeline that looks like this, and I'm actually going to rerun it while I describe what it does. So let's execute the pipeline, and boom. What we're doing is we're actually taking that Kubernetes cluster that we spun up earlier, and we're provisioning directly from the Docker store both WebLogic and MySQL in a parallel pipeline. And then we're deploying the domains and the schemas, and we're applying tests to that to ensure the cluster is healthy. Now, what this gives me is a reproducible cluster every single time to ensure that I have the same software on the same versions every single time my developers and my organization want a new cluster. Fully autonomous, one-click availability. So, the next part of the demo, we talked about serverless computing. Well, we're going to write some logic against this cluster. We're going to turn to the FN project. FN project is an open source serverless compute platform that will allow your developers to build small bits of code and deploy those to both a multi-cloud and an on-premise environment. If you haven't heard of serverless computing, it's quite a new trend where it takes the architecture and it makes it so that developers really don't have to think about any of the plumbing. But more importantly, it reduces the cost of your organization through less operations and only charging for the time your particular functions run. And it reduces the attack surface area of your software. So again, this theme of autonomous and security are very important, and this helps you do that. So I'm going to start with, let's go to our terminal here. And if you can see this, we have 6 functions all around this theme of a travel agency. These functions, what they do is they book flights and hotels, they get and process reservations. So we've got 6 functions here. And you'll also notice that we have another worker.yml file. It's the same type of pipeline that we built for that reproducible infrastructure before to build a reproducible software pipeline as well. So what I'm going to do is just change this file here. Let's get my new change. And I'm going to do a git push, which takes this and pushes it right into the GitHub repository. And that's going to automatically trigger, let's find our, that's going to automatically trigger another pipeline here, which, if I can click on the right run, is automatically taking those functions, building the containers, pushing them to a repository, and registering it with my serverless service. So this will ensure as your teams grow and your applications grow in complexity, you're always ensuring that the highest quality software makes it into production. This is really, really important. And so this is a pipeline that will essentially do that for my travel agency. And so as those move their way through the pipeline and they generate some push to the service, we will see in our FN open source user interface that we now have 6 functions that have been deployed to this service. I can trigger these functions from the interface. I can wire them up to trigger from other events. Thomas talked about events earlier. I've actually gone ahead and pre-configured this so that when I get an event from a new object in the Oracle Cloud Infrastructure object store, it will trigger what we call a flow function. So let's go ahead and do that. I'm going to upload an object. And what I'm going to take from my desktop is a CSV file, which is a comma-separated file with 10 reservations on it. And when I click Open and Upload, in just a moment, we're going to see a new flow triggered on this user interface, which is a special user interface that shows me a workflow series of what we call a flow function. And this is a very powerful application for developers because it allows them, and here's our new flow. This allows developers to easily debug complex applications for higher level workflows and sequencing of functions. And it's beyond the scope of this particular demo, but you can see that we're taking each of our reservations and we're starting to fan out into a lot of different functions that are running, all serverless, all in the cloud, auto-scaling. As a developer, I'm not thinking about any of this. I can click on any particular function here. I booked a hotel here. If I scroll down, I can actually see the entire call log through the function sequence all the way down to the beginning where the sequence was triggered. So this is a very powerful concept for developers. In review, what we demoed today was 3 things. We launched a Kubernetes cluster with a single click that's fully autonomous and highly available on the Oracle Cloud using Oracle Kubernetes Engine. And then we took that cluster and we provisioned it with popular software packages from the Docker store. And then finally, we used the open source FN project to build and deploy functions to the cloud. And what you'll notice during this demo is that we didn't talk about any of the plumbing or the stuff that we don't want to worry about. It's a new generation. It's where we can just ship code, just think about logic, and the system takes care of itself. It's truly a modern app dev experience built on an autonomous system.
Thank you very much, Ed. Great job. So we brought the same capability to analytics, okay? When we talk about analytics, 3 differences in what we're doing. The first one is we're allowing you now to analyze not just structured data, but images, sound, video, text, and sensor data. So any type of data, okay, from any source. And then most importantly, there's technology that we have built that makes it easy for anybody to do the analysis, okay? Not only the autonomous data warehouse, where you don't need to have a professional DBA if you want to do analysis, but the analytic tools have also been simplified to make it easy for any person in any department to be able to do analysis. And all the skill set you need is either know how to load an Excel file and have a browser. Okay, now, to prepare the data, we have an autonomous big data cloud, okay? So on top of our infrastructure, we built a fully autonomous stack, okay? You can load data in 2 ways. You can move it in batch into our object store, or you can stream it in over our Kafka service. When the data comes in, you can spin up a cluster. You can either say, I want a Hadoop cluster if you're running MapReduce or Hive, or you can say, I want a pure Spark cluster if you're just going to run Spark calculations. On top of that, we provide you a data preparation pipeline where you can extract entities, cleanse the data, enrich it, blend it, and then you can use our machine learning capabilities to run a variety of different algorithms. You can run statistical processing, you can run TensorFlow if you're doing deep learning on the data. The output goes into the analytics cloud, where you can model your data sources, you can visualize it in a variety of different ways, and then you can collaborate with other people around the data. Now, one of the important things you'll see that we're working on is where we see the human interface going. Okay, so if you look at the human interface, people say, well, employee self-service in HR is really about putting the application in the hands of every employee. However, if you look at most mobile applications, they really haven't fundamentally changed. And the last advance in user interface technology was in 1986 with the introduction of the graphical user interface. Okay, so what we're working on is something we call the ambient user interface, or ambient human interface, which is the interface is always with you. And you can interact with it in a variety of different ways. You can certainly go to your web browser and access the application. You can also access it over a mobile app. But increasingly, we see people asking questions to a system over messaging using what's called a chatbot. Okay? But messaging is just one way to interact with this virtual assistant that we have built for our entire platform and applications. The other mechanism is to talk to it over voice. Okay? Imagine you're walking from one place to another, between one meeting and another, and you get a request, can you please approve this purchase order for me? What you can do is to say, find me the purchase order. You can just speak for Cisco Systems, which happens to be the customer, approve it. And it hugely eliminates the need for you to have to go in and log into an application over a VPN, access a console, and do approvals, for example. So this ambient human interface, we're going to deliver through our mobile cloud platform to a variety of different device platforms. Okay, you can use it on the web, you can use it on apps. We support a variety of different voice platforms. We're going to show you Alexa, but you can do any other voice platform you want. And we support all of the common messaging platforms available in the market. Okay? So Suhas Ulyar from developments here. Suhas is going to show you the combination of what we're doing with our HR apps, bots, and voice.
Yes.
Welcome, Suhas.
Thank you, Thomas. So to demonstrate the features of the autonomous mobile cloud, I'm going to use a use case on campus recruitment. And in this use case, I have a company called Vision Technologies that's partnered with the university, First University, to recruit their graduating employees. Now, I have two parts of the demo. In the first part, I'm going to be a student, Pat, and I'm going to be interacting with the recruitment cloud using a conversational interface that Thomas has described. And in the second part, I'm actually going to be a line of business in HR that's actually going to show you how we're going to build these applications all driven by AI. Okay? So the first thing here is I'm the student here, Pat, and I'm actually going to be displaying this off my device. You're seeing my display off the screen. So again, nothing like a real demo. And here, the company has used the recruitment cloud and sent me a notice or sent me an email telling me about the marketing campaign that Vision Technologies and First University have put together. And so I'm going to click on this email that I got, the link, and it navigates me to a very specific portal that was this part of the recruitment cloud that was extended for First University. So we'll also show you how we extend that capability from the recruitment cloud. So here I can take a look at all my careers, the different projects. So I'm interested in looking at what kind of career I could have at Vision Technologies. So I'm going to click on careers. And it sort of gives me some information about different types of careers. Now, what's happening behind the scenes is that the recruitment cloud has taken a lot of the information that the university has given about me, as well as looked at other information from LinkedIn and Twitter and other sources. And we use artificial intelligence and machine learning to start providing recommendations. So here, the recruitment cloud has basically recommended that based on sort of my likes and dislikes, my academic background in the university, that maybe AI is a good career for me and that I should look at applying for this. So up comes the pop-up, and I said, that's interesting. And I also see that it's actually got a link to a career advisor chatbot. So I'm going to now click on the career advisor chatbot, and automatically it sort of signs me into Facebook Messenger, which is what I'm using in this case, and now starts a conversational interaction with the Vision Technologies chatbot. Now, what's pretty cool about this is again where we demonstrate the features of the autonomous mobile cloud, is that because I logged in Facebook using my credentials, was able to also find out who are some of my friends in my network who actually worked for Vision Technologies or who had some interaction with Vision before. So it then also asks me if I'd like to message them, and what better than having your friends recruited into your company, right? So it automatically gives me this and says, would you like to message anyone? In this case, I'm going to find out, where is this career going? Is it a dead-end job, or is this really exciting? So I'm going to ask a question. What is a typical career path for this role? Okay? So now, this is sort of where I have this conversation interaction. So the bot comes back and says, okay, people transition into both business and engineering careers. I said, this is very interesting. I was like, I'd like to apply. So, okay. I would like to apply. Says, okay. It basically looked up different scheduling interviews and said there's a campus event on March the 20th, and it has the following times available. So I click on the 11:30 to 12:30 slot. So I'd like to wake up a little bit late. And it confirms a 3:20 meeting on the 11:30. So I'll say any other questions. I'll say no. And basically thanks me, and I'm done now setting up. This is an example of a conversational interface. Now, Thomas, you mentioned, sorry. So you're not moving.
Hit escape.
There. Right. So you mentioned about Alexa. So as a student, I'm not very good at remembering things. So I'm going to use Alexa to interact, and this is an example of using a digital assistant to interact with, the Oracle digital assistant to interact with the bot. So I'm going to first start. So I have Alexa here. I put on mute here. So I'm going to unmute Alexa here. Then I'm going to ask a question. Alexa, ask Vision Technologies bot, when's my next appointment?
Hello, Pat Lee. Your interview at Vision AR is scheduled for March 20th at 11:30 a.m. Don't forget, the recruiter's name is Howard King. Would you like me to set a reminder for you?
Yes, please. That would be great.
Okay. Reminder created for 1 hour before your meeting.
Alexa, by the way, what should I really wear for an interview?
I would recommend business casual. A tie is not necessary. Good luck.
Thank you. So good. I'm already dressed for the interview then. All right. So that was sort of the first part of the demo where Pat, as a student, I was interacting, and I showed you a few different types of interactions. First, I interacted with a mobile portal. Artificial intelligence gave me some recommendations. I then used the chatbot to interface and set up an appointment. And then I used my digital assistant to make sure that I'm reminded of where I should go and what I should wear. So now I'm going to change, and I'm going to switch to a second persona. And the persona here is the line of business HR person that's going to be using one of the components of the autonomous cloud, the autonomous PaaS, to actually build this application. So I'm not a developer. Now, most of you know 4GL, right? So Thomas was the old 20-year-old 4GL. So we actually decided to do an AI GL. So in this new way of building applications, what we're doing is, so typically when you build an application, you pretty much use something like a stencil or something to design the application. So you may have an image that's come from your design department or so to build an application. So on the right, you see on the screen, on the little top there, I have a little image of a screen capture. And what I'm going to do is, I'm just going to go drag and drop that into my design surface. So all this is just an image. This is not an application. At this point in time, this is just an image, right? What we're doing here is behind the scenes, we're using AI and machine learning, we're using image recognition and object recognition to automatically take this image and create an application without even bothering my fingers with a drag and drop, okay? So what has happened behind the scenes is that automatically, it's hard to see, but it's already created the tabs, it's created the cards, it's created the headers, everything that I need, and all I need to do now is just go make some modifications. For example, if I want to change the background, if I want to change the label, that's all I do. I don't need to drag and drop any component of the web application on the screen at all. To test this, all I do is I go from the design layout to the live layout, and now I have the same application that you saw earlier on my mobile device now within the development environment that I have here. Now, this is a fully responsive application. So today's world, everyone uses a mobile-first paradigm. But if I still wanted to have this application run on my desktop or browser, all I have to do is just sort of go to the desktop browser icon, and it automatically repositions itself into my desktop browser application. The last step here, what I want to show very quickly, is how I would, as a line of business user, enable this digital assistant as part of my flow. So I'm going to go to my bot icon, which is on the left here, click on that, and what you see here is, at the moment, a pre-configured flow, which is sort of what you saw in my interaction. So if I wanted to add another interaction to this, I'll just come down to the text box here, drag and drop that, and now I can go configure this, and it's now part of my flow. Okay? So this concludes my presentation, a demo, and shows the value of the autonomous mobile cloud.
Thank you.
Thanks, Thomas.
Great job.
Yes.
So we showed you two things there. First is the new human interface that we believe will be very common for business applications, right? If you're a consumer and you're comfortable with voice assistants, we're introducing a voice assistant for Oracle, a digital assistant. You can use any voice platform. We work with all the common voice platforms on all the mobile devices out there. And we also showed you how easy it is to build applications using our Visual Builder platform. Now, the same way, we offer, as part of the platform, an integration cloud, fully autonomous, to allow you to build integrations between different systems, and an AI and machine learning platform where you can experiment with data sets and models of various kinds. And let's look at software as a service. Okay? We started this journey to offer a full suite of applications. A full suite consists of enterprise performance management to allow you to define your financial plans, your budgets, do your financial consolidation and reporting. ERP, general ledger, projects, portfolio management, procurement. Supply chain, design your product, manage product lifecycle management, source with sourcing and direct procurement, do demand supply planning, discrete manufacturing, logistics, warehouse, transportation management. A full human capital management suite, starting with candidate identification, candidate sourcing, alumni recruiting, general recruiting, onboarding, giving a person compensation benefits, giving them goals, learning, succession planning, talent management. So it's every part of the suite is a full platform. I'm going to show you CRM, for example, how you can market, how you can bring people from a marketing campaign into a sales system, allow them to configure price and quote, handle order management, and service. One platform. There's 390 modules on our SaaS suite, available in 39 countries and being used today by people from 187 countries in the world. Now, where are we taking our software as a service platform next? First, we provide you the capability to extend our software as a service using our infrastructure and platform. And we showed you an example in recruiting where we used our mobile platform to extend recruiting. But a second example is where we're introducing artificial intelligence inside the applications. So today, many applications are written to be heavily rules-driven. And the problem with business rules is they can become extremely elaborate and extremely cumbersome to maintain. So imagine you are a contact center person working in a telecommunications company. Call comes into the contact center desk. From the time the call comes in to the time it's routed to you, in most contact centers, 30 seconds. You receive the call. You have to understand who the customer is, what issue are they upset about, and what product of the many, many different products that I have do I recommend to them. AI can do that way better than any person can figure out within the 1 minute you have to do that. So we've introduced as an AI as a platform inside every part of our application suite. In ERP, it'll let you find the best price. It'll allow you to identify if people are doing maverick procurement, meaning buying things they're not supposed to buy. If there is inaccurate reconciliation in transactions in the ledger. In HR, it allows you to find the best candidate for recruiting. It allows you to identify what's the best career step for a person. And in CRM, it allows you to identify across 6 different modules what's the next best action to take to help this person. So the way we do this in CRM is we take data from a variety of different sources within our applications. You can also load in your own data. We cleanse and blend and enrich that data in our data cloud. And the reason that's important is if you have poor quality data, no AI algorithm will give you accurate recommendations, because generally garbage in, garbage out. So you have to have good, high quality data to be able to reason on it with AI and machine learning, and then we feed that back transparently into the CRM application. Alistair Galbraith from Development's here to show you that. Alistair, welcome to CloudWorld.
Thank you, Thomas.
There you go.
Thank you. And Thomas mentioned that there are 390 modules that make up our SaaS services, and given the 8 minutes I've been given to go through a journey using all of those, I did cheat a tiny bit. I grabbed some screens to illustrate the journey. I talk fast and I've had a lot of coffee, but I want you to try and understand where I'm going. So what I want to do is introduce a couple of personas. We're going to start out with Jane Smith, who's the VP of IT at a made-up company called Acme. Alex Matthews, who is the new sales rep working with her at a company called DDX, which sells servers, some cloud services, and what we've called System. This is really the Oracle CX suite and adaptive intelligence working together. Now, Jane's got a big pile of legacy servers that are about to come off maintenance, and we know about this. And what AI is doing is monitoring this interaction and generating a couple of events that are happening behind the scenes. And I want to walk you through how this journey works. So we'll start out with Jane. And Jane gets this inbound email saying your maintenance is expiring. Not a giant shock for her, because she already knew that. But this is an opportunity for us to engage her with some other information. So as well as the one-click link to renew, which the analysis shows she's not going to do, we also see a couple of other pieces of interesting content. One is a blog article that's taking her through to the DDX website to find out more information about alternative services that might be available to her. And one is a bespoke bundle that's been packaged together to help her more easily transition to the cloud. Now, she's actually kind of interested by the blog article. She's had a good relationship with DDX, so she's going to click on the blog article to go onto the DDX website. And this is an example of us merging a B2C-like experience into a B2B storefront. But the key thing here is actually the consistency of the recommendations. You can see on the right-hand side that we've got the same recommendations that were in the email. We've got the bundle coming in, together with some other content that might keep this interaction going. Now, Jane reads through this article, maybe a couple of others, and she's intrigued by the bundle. So we're going to click in and view the bundle. Now, in this case, this bundle has been put together by the DDX merchandising team, one of a set to make it easier for customers to move to the cloud. But we know about Jane's assets. We know what service that she's got. We know what services she's using, so we can recommend the exact set of features that she'd need. And here, AI is coming into play again. We generate what we call the next best offer. We know that now is the right time to engage Jane with chat. Now, we've got a selection of technologies available to us, chatbot or real human chat, but this is the right moment to just get Jane in front of a person. We know Alex is at his desk, so we offer to join the two together. Jane's ready to talk, so she clicks into chat, and like all of us being sold to online, we're a little incredulous that we didn't know about this wondrous thing earlier. So she's going to ask a question. Sounds great. What are the problems with this? So let's go back behind the scenes and take a look at how Alex is starting to interact with the same alert that was generated for him. So we drill into Engagement Cloud, and here you can see Alex's task queue. And right at the top, we've got an AI activity that's been generated, warning him that there's churn that's likely to happen with this specific account. Now he's going to drill into the Acme account, and here we see a great customer 360 that allows Alex to get a sense of the account relationship very quickly. We're seeing at the top, very high churn risk is likely. We see that we've sent out a renewal offer that Jane's just blatantly not going to take. We're seeing some next best actions and some more details from AI to tell Alex what to do next. You can see down way in the bottom right-hand corner, you see notice that we've sent out to Jane this bundle offer. Now, Alex can drill in because he's got more understanding of what these things are, look over at the churn risk and see why AI is telling him this account is at risk. He's new, he didn't know much about this account, so it's great that it's been put in front of him. Now, this is the moment that handily the chat request comes in and is routed through to him. And here we can see chat inside Engagement Cloud with the question coming in from Jane. And as Thomas said, AI is a much better tool to provide Alex with the interactive context here than him trying to work out what's Jane talking about, what's she asking. So here we've got a recommendation that he answers this question with this best answer, which he can just choose to insert. He can edit it and then pass that back to Jane. Jane is now, as all of us hope at this point, sold, but she doesn't like the pricing. There's a shock. Now this integrates nicely with CPQ. So we see in configure price quote the pricing that was offered to Jane. This is her agreed account pricing on her B2B account. We can see that the margin is really good, which is why we've got a price score of 9. She's got her standard discount, but again, intelligence here tells us she's not going to sign this deal. And we can analyze this and say the best balance of Jane signing this and you not giving this thing away for free is 32% discount, which Alex can go ahead and accept. This exceeds his personal discount limit, so again, an analysis tells us the time it'll take to go through your management approval process is about 11 hours. He can set expectations with Jane. It's all about expectation management in this new world of great customer experience. So we're going to go through, set the expectation with Jane, and submit this in for workflow. Alex's boss, Paula, gets this inbound email for her to go and review. And as Thomas said, we could just as easily do this with an interactive digital assistant. In this case, she gets a very quick summary of the data that she needs, as well as a recommendation from AI that she accept this. The next best action is, this is a good deal, we need this, just go ahead and approve it. So she approves that transaction. Jane gets the automated notice coming out saying, hey, your quote's ready, I've made the pricing better for you. So she can go back into the online site here, see the specifics of the new better pricing. This is exactly what she wanted. She's had a good relationship with DDX. Why not just stick with them and move to the cloud rather than trying to evaluate something else? So she accepts this quote, takes her through a very straightforward B2B purchasing process, and then there we go, the order's placed. So at this point, Jane's happy. In fact, in the world of mobile, she's already on her way to Hawaii. And Alex, our sales guy, hashtag winning for him. He's just gone from a customer he didn't know to a closed account in the space of, looks like 6 minutes so far, Thomas.
That's great.
So let's take a look behind the scenes, shall we? What you saw was the Oracle CX Suite and Adaptive Intelligence working together. And the key thing here is this isn't just recommendations for Jane. You saw these spanning multiple channels, multiple personalities, keeping this great consistent journey moving slowly through. Now, if we drill into what's behind adaptive intelligence, there's some really cool technologies at play here. I've got no tie, I'm a developer, so I'm excited by this stuff. Here we've got machine learning, neural networks, and NLP working together, but what makes our approach different is domain-specific understanding. We know about the offers, we know about the subscriptions, we can analyze the bundles and the churn likelihoods and feed this into the NLP engine. What is important when you drill in, we saw NLP working in chat, and we saw some other technologies working behind the scenes. All of this is driven by data. You can't just go in and be immediately successful with no data behind the scenes. So we're pulling in a series of pieces of data, the cleaned data that's coming out of the CX Suite. So that's nice, neat customer records, opportunity data. We're looking at some of the data that's coming from Oracle Data Cloud, which is the biggest repository of consumer advertising data out there. So that's starting to look at Jane's intent. We know that she was looking at competitive sites. She was reading articles on Financial Times about moving to the cloud. We're also looking at business data that's driving into the behind-the-scenes algorithm. Now, data can mean anything to anyone, and I've tried to just pick some of the examples that we used here. We saw the data that was coming out from the account. There's a huge amount of account data in Engagement Cloud that's feeding into AI. We saw Jane's behavioral data as she wandered around. We saw Data Cloud data, as well as the business data. Oracle sources most of this and synchronizes it automatically from either Oracle or one of our 1,500 data partners. So last but not least, Thomas, we saw a nice synchronized journey where DDX made $453,000, if I remember the number. Jane was thrilled. We saw a move between channels, and all of this was empowered by AI. There we go.
Thank you. Thank you.
Thank you, sir.
Great job. So we showed you AI in a different context. Rather than allowing you just to build your own algorithms, combining data and domain-specific algorithms inside our applications so that you get much better business results from your business process. Two other areas of technology that we're innovating in. One is blockchain. Okay, so our central view is that blockchain allows you to do two important things. It takes functions in a company or between companies that are highly centralized and allows you to distribute them on a distributed transaction platform. And we're working with customers in financial services to help use blockchain for intercompany transactions. We're working with customers in retail to allow them to build loyalty networks where you get the equivalent of credit card points, but on a loyalty network on top of blockchain. Working with companies in manufacturing, in discrete manufacturing, and then in logistics, where they want to liquefy the supply chain so that you as a customer say, I want this thing delivered to me at this time, and then the entire supply chain from where it's picked up from the warehouse, how it's automated on the transportation network and delivered to you, that entire flow happens over a blockchain. And so for us, blockchain enables a number of things from paperless transactions, intercompany reconciliation, as well as applying to a variety of different domains. The other area that we're announcing a lot of new things tomorrow at our Modern Finance event is IoT. Okay, so our general view is that everything in the world eventually will be digitized. People carry devices, they're digital. Medical devices have sensors on them, they can be monitored. Transportation systems can be monitored. Trucks, containers can be monitored. So everything in the world can be monitored. And we provide a suite of IoT applications to allow you to monitor assets, people, and things. And we're going to show you just very briefly with a video what we believe the future of industrial manufacturing looks like.
Industry 4.0, the fourth industrial revolution is here. Machines are self-configuring and adapting to efficiently create personalized products. To succeed in Industry 4.0, we will need smart sensors onboarded to a computationally superior IoT platform, big data analytics, algorithms, and machine vision technologies to derive real-time context-specific insights, as well as augmented human-machine interfaces and mobile devices to communicate real-time instructions to the physical world. Oracle IoT Production Monitoring Cloud is designed to help factory managers with these Industry 4.0 goals. Imagine a factory manager who manages multiple factories, producing a range of products. To simplify digital interactions with physical machines, Oracle IoT Digital Twin provides a consolidated view of asset performance with a sophisticated interface for telemetry and control. Oracle IoT Production Monitoring Cloud has digital twins of all factories and products, and therefore tracks key operational performance metrics to help the factory manager gain real-time visibility to understand the current status of factories, products, and machines. It helps the factory manager to identify a specific factory, product, or machine that requires attention via the Comparative tab. The historical view of the performance indicator helps to assess if the poor performance factory is a new problem. The factory manager can further diagnose and identify the specific cause that contributes to poor production yield. In the product view, the factory manager can identify the bottleneck machine and study its health via real-time sensor data. Using the business-friendly rules engine, Oracle IoT Production Monitoring Cloud can notify factory managers of machine health anomalies. Oracle IoT Cloud uses predictive models for multiple sub-assemblies to predict the probability of failure of the overall asset. Using the knowledge base of diagnostics code and contemporaneous sensor data, Oracle IoT Cloud uses built-in artificial intelligence algorithms to find the most likely cause of failure. To resolve issues, IoT Cloud prescribes the best course of action using the built-in recommendation engine. Maintenance work orders are also automatically created. Oracle IoT Cloud uses autonomous smart algorithms, which help factory managers reduce unplanned downtime. Factory managers can get a closer look using augmented reality capabilities in the Oracle IoT mobile application. With integration, Oracle IoT Production Monitoring Cloud can communicate anomaly incidents to automatically schedule maintenance. Further, powerful analytics will generate predictions of key performance metrics that factory managers can use to improve factory uptime and reduce inefficiencies. Industry 4.0 holds the promise of cooperative mass production factories, where products, machines, and personnel communicate seamlessly. Get there quicker with Oracle IoT Production Monitoring Cloud.
So what we've integrated there is a number of things: machine vision, IoT to monitor the systems, our AI and ML algorithms, and integration with supply chain. So what you've seen from us is where we believe the technology, where we're taking Oracle next. High-scale, software-defined virtual data centers. A fully autonomous platform to allow you to manage your data, build applications, and do analysis. And a suite of SaaS applications where we're integrating artificial intelligence, a new human interface, and cutting-edge technology like blockchain and IoT. Today, over 20,000 companies around the world have over 50 million users processing over 60 billion transactions every day in 29 regions around the world. They get real business benefit, and they're able to exploit Oracle's latest R&D advances. And we encourage each of you to have a wonderful event at CloudWorld, but also understand how this technology can apply to your organization. Thank you very much.